Integration by parts. First example, integral 1 to e ln x all squared dx. We're going to let u be equal to ln x all squared. Du is 2 times ln x times 1 over x dx. dv is equal to dx. Integrate dv and you get v. v is equal to x. Applying the formula, integral u dv is equal to uv minus integral v du. Alright, let's put this in. U times v, that's x times ln x all squared minus integral v, which is x, times du, that's 2 ln x times 1 over x dx. The x's cancel out. Let's bring the 2 outside the integral. We get x log x squared minus 2 integral log x dx. Now let's reapply integration by parts to this integral. Let u be equal to ln x. Du, its derivative is 1 over x dx. dv is dx and its antiderivative v is equal to x. Alright, so we get u times v, that's going to be x ln x minus integral v, which is x, times du, that's 1 over x dx. Cancel these and you get x log x minus integral 1 dx, that's x log x minus x. And this is the result of this integral. Now let's put it all together and we get x times log x squared minus 2 times x log x minus x. And now let's evaluate it from 1 to e. Applying the fundamental theorem of calculus, which is integral a to b f of t dt, this is equal to f from a to b, which is equal to f of b minus f of a. Alright, let's put e in. We get e times log e all squared minus 2 times e log e minus e minus, let's put 1 in, you get 1 times log 1 squared minus 2 times 1 log 1 minus 1. Now log of e is equal to 1. Log of 1 is equal to 0. So log e is 1, log e is 1, log 1 is 0, log 1 is 0. So we get e minus 2 times e minus e, that's 0, minus, that's 0, minus 2 times 0 minus 1, that's negative 1. The answer is e minus 2. Notice we have 3 minuses. Minus, 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 that makes a negative. That is the answer. Okay, let's look at another example. This one will involve integration by parts and also has an inverse trig function in it. So exercise 2. Here we have integral x tan minus 1x dx. how do we choose u and dv? Well, here's a good strategy. Use a light principle. L is for logs, like ln x. I is for inverse, like tan minus 1x or sine minus 1x. A is for algebraic functions. Algebraic is like root x squared. T is for trig functions, like sine x, cos x. And E is for exponential functions. Exponential, that's like e to the x, 2 to the x. Alright, so in this case, we can see that inverse trig function comes before algebraic, so the first choice for u is let u be equal to tan minus 1x. And I should say that the light principle, this strategy, gives you the first choice for u. Alright, so u equals tan minus 1x, that's u. Du is 1 over 1 plus x squared dx. dv is x dx. V is x squared over 2. So we get u times v, that's tan minus 1x times x squared over 2 minus integral v, which is x squared over 2, times du, which is 1 over 1 plus x squared dx. Let's pull out the 1/2 from the integral. We get tan minus 1x times x squared over 2 minus 1/2 integral x squared over x squared plus 1 dx. Now we're going to have to do long division. Whenever the degree of the numerator is larger or equal to the degree of denominator, we have to do long division first. Okay, x squared divided by x squared plus 1. X squared goes in x squared 1 time. 1 times x squared is x squared. 1 times 1 is 1. Subtract, and we get negative 1 remainder. This here is the quotient, so that's quotient. This here is a remainder, and this is the denominator, that's denominator. Okay, so we're going to write this x squared over x squared plus 1 in terms of the quotient plus remainder over denominator. 1 plus negative 1 over x squared plus 1. And this will allow us to do the integration. Okay, so let's write the negative 1/2 outside. Let's carry through the previous work. That's tan minus 1x, x squared over 2. So what we get is tan minus 1x times x squared over 2 minus 1/2 times x minus tan minus 1x plus c. And this is the answer to the integral. Okay, let's do another example. This example is going to be a little bit more difficult, and it involves integration by parts, but it's also a recursive type of example. Okay, example 3. Here we have integral e to the 2x sine of 3x dx. So let's let u be equal to e to the 2x. du is 2 e to the 2x dx. dv is equal to sine of 3x dx. v is antiderivative, that's negative cos 3x divide by 3. So we get u times v, that's negative 1/3 e to the 2x cos 3x minus integral v, which is negative cos 3x, divide by 3 times du, which is 2 e to the 2x dx. Okay, let's pull out the constants from the integral, so we get negative 1/3 e to the 2x cos 3x minus minus is plus 2 over 3 integral e to the 2x cos 3x dx. Now we see that we sort of get the same type of integral as we had originally, but it's a little bit different. We've got now cos 3x. So this is an important note. Since u was chosen to be e to the 2x, we have to make the same choice here. Otherwise, we'll just go in circles and won't be able to solve the integral. So we're going to let u equals e to the 2x du. It's going to be 2 e to the 2x dx. Dv is cos 3x dx. V is integral cos, that's sine 3x over 3. So let's solve this integral with u times v, that's e to the 2x times sine 3x over 3 minus integral v, that's sine 3x over 3 times du, that's 2 e to the 2x dx. Okay, let's bring out the constants. So you get e to the 2x sine of 3x over 3 minus 2 over 3 integral e to the 2x sine 3x dx. So let me call this double star, and this is a result for double star. But you're going to notice something. The integral that we were looking for, which is e to the 2x sine 3x dx, reappears here. So let's call this integral I equals. So we've got I is equal to e to the 2x negative 1/3 e to the 2x cos 3x plus 2/3 times e to the 2x sine 3x over 3 minus 2/3 times I. And it's very important to have this I here. Okay, now let's do some algebra and solve this. Okay, so what we get is we have I is equal to negative 1/3 e to the 2x cos of 3x plus, and here we have 2 over 3 times 2 over 3, so that gives us 4 over 9 e to the 2x sine 3x, and we have 2 over 3 times negative 2 over 3, that gives us minus 4 over 9 times I. And now let's bring this over, and you get I plus 4 over 9I is equal to negative 1/3 e to the 2x cos 3x plus 4 over 9 e to the 2x sine of 3x. This is 9 over 9 plus 4 over 9, and that's going to give us 13 over 9I is equal to negative 1 over 3 e to the 2x cosine 3x plus 4 over 9 e to the 2x sine of 3x. multiply this side by 9 over 13, and multiply all of this by 9 over 13. This cancels. We get I is equal to negative 1/3 e to the 2x cos 3x plus 4 over 9 e to the 2x sine 3x, all multiplied by 9 over 13. If we simplify further, we get negative 1/3 times 9 over 13, that's negative 3 over 13 e to the 2x cos 3x, and the 9 cancels, we get plus 4 over 13 e to the 2x sine 3x. And don't forget to put the constant of integration c. That is the answer. Alright, so it's very important when you do this type of question to notice how the integral e to the 2x sine 3x reappears in the process of solving the integral. This is the recursive nature of this sort of problem. Okay, let's look at another example. Example 4. Alright, example 4. Integral x cubed log of x squared dx. Recall ln of x to r is r ln x. So let's write this as x cubed times 2 log x dx. Let's bring the 2 outside and we get 2 integral x cubed log x dx. Okay, let's make a choice of u equals ln x, and du is 1 over x dx. dv is x cubed dx. v is x to the 4th over 4. Now you might ask, how do you know to make u equals ln x and dv to be x cubed dx? One way is to use the light principle. That's like a little trick that we can memorize. Another way is to think of it as choose u easy to differentiate. Choose u easy to differentiate. Choose dv easy to integrate. And perhaps this is a more natural way of thinking about it. If we let u equals ln x, it's easy to differentiate it. But if you try to make u equals x cubed and dv be log x dx, then integrating log x is another integration by parts, so it would be much more difficult. So you can use either principle that makes it easier for you. Okay, so let's apply this. We get u times v, that's x to the 4th over 4 times log x minus integral v, that's x to the 4th over 4 times du is 1 over x dx. And we get x to the 4th over 4 log x minus 1/4 integral x cubed dx. We get x to the 4th over 4 log x minus 1 over 4 x to the 4th over 4. 2 times all of this plus c. Let's simplify a little bit further and we get 1/2 x to the 4th log x minus x to the 4th over 8 plus c. Alright, thanks.